Hey, this is Alireza here again. In today's video, we're going to configure EIGRP in classic mode, in traditional mode. Guys, because I don't want to make this video too long, I don't want that. If you want to dive deep into it, into EIGRP concept, you can flash back to my previous video because I completely explained what EIGRP is and how it works. And you can know about the mechanism and all kinds of the packets that are working in EIGRP topology. Well, in this video, we're just configuring EIGRP in classic mode and very quickly, and then we're going to configure EIGRP in named mode in the next video, which is the newer version, and all of the new technologies and modules are working with the named and newer version. You may be wondering why we shouldn't just configure and learn about named mode, the newer version. I have to tell you guys that EIGRP classic mode is still widely used in the world, and many countries configure classic mode in their topology. So you must know about classic mode, how to troubleshoot that, how to show the configurations, and etc. Okay, let's jump into the laboratory. As you can see, in our scenario, we got 4 routers here, router 1, router 2, and router 4. And there is some network 10, that we're supposed to see this network from router 1, right? We have configured pretty everything, the IP addresses on interfaces in the routers, and even I assigned the IP address 192.168.10.10 with the /24 to the network 10 in this PC. And I also configure all of the IP addresses to the interfaces in all routers. And we just have to configure our EIGRP with the topology, because I don't want this video too long. Okay, to start the task, we start from router 1 right here. To start the task, we're going into global mode. And then to configure EIGRP classic mode, we just have to type router with question. You can see the potential commands that you can input. We have, as you can see, we have router EIGRP. And then with question mark, you can see that you can configure your EIGRP in 2 modes. In classic mode, which you have to assign AS number, and newer version, the named mode with word. So in this video, we're not going to configure in named mode, so we have to assign some AS number. I'm going to assign, for example, 100. Listen guys, if you configure and assign some AS number in your topology, you must set up the same AS number in the rest of the routers. Remember that. And after getting to the router EIGRP, first of all, I'm in habit. I'm going to turn off auto. Oops. I'm going to turn off auto summary. Many of you don't know what auto summary is, and if you're wondering what does auto summary do, I have to tell you that in Cisco, auto summary is going to summarize your roads to classful network automatically, which causes many problems and conflicts in the topology, which we don't want that. So we have to turn this auto summary off to avoid getting to the trouble with the topology in the future, right? So with no auto summary, this feature is going to be off, right? And then we're going to specify the network. In router 1, the neighbors network, as you can see, is 10.10.10.0/24 and 20.20.20.0/24. First of all, network 10.10.10.0 with wildcard mask. We don't input subnet mask, guys. We input wildcard mask with 0.0.0.2255, right? And the second network, which is network 20.20.20.0 with wildcard mask. And after that, we have done with this router with end and write. All of the changes are saved after reloading the router. And let's jump into router 2, doing all the same here. Router EIGRP, remember AS number, the same AS number. What was that? It was 100. And then guess what? Right, turning off auto summary to avoid summarizing your roads to classful network, to avoiding getting to the trouble in the future with your topology, right? No auto summary. And then we're going to specify the networks. Network, what is the network? What are the networks besides router 2? There are two networks, right? 10.10.10 and 30.30.30. We firstly specify this network with wildcard mask, and then network, as you can see, it's saying that new adjacency is discovered by gigabit Ethernet 2/0, right? And it clearly tells you guys that 10.10.10.1, which is belong to router 1 gigabit Ethernet 2/0 here, and it clearly says that you have new adjacency. The neighborship is establishing, right? And after specify the first network, there is another one, network 30.30.0 wildcard mask, and end with write. Let's jump into router 3. Do the same, guys. Router EIGRP AS number. What was the AS number? It was 100, right? 100. And then we specify the networks. And as soon as we specify this network 20.20.20, the router 1 neighbor, right? And wildcard mask, the alarm has shown, right? And it says that new adjacency is discovered, and the neighbor with IP 20.20.20.1 in gigabit Ethernet 3/0 in router 3, this interface is connected to our new neighbor, router 1, with IP 20.20.20.1, which is router 1 IP address on gigabit Ethernet 3/0. And then we specify the other one with network. What is the other one? 40.40.40. Guess what? 0. Wildcard mask. Great. Now let's jump into router 4, the last one. We do the same. Router EIGRP AS number 100. Listen, guys, if you don't assign the same AS number in your topology, your scenario is failed and it's not going to work well. So you must configure AS number in all routers in your topology. All right, we specify the network. Oops, sorry, I forgot about the no auto summary in here and in router 3. So firstly, I'm going to turn off auto summary in router 4 with no auto summary, and then we just do the same in router 3. We get into EIGRP router with AS number 100 again. With AS number 100, and we turn off auto summary. Okay, great. Now let's jump into router 4 and we specify the networks, which is 30.30.30 with wildcard mask. And as soon as we specify that, you can see the alarm is shown that new adjacency is discovered. And we have new neighbor here. Neighborship in EIGRP is very important, guys. If you watch my previous video, I completely explained what neighborship and adjacency are. I recommend you to watch that. And then now we specify the second network, which is 40.40.40.0 and wildcard mask. Great. And the alarm for new adjacency is shown right here with right. And now we have done with all the routers in this scenario. And if I go, for example, to router 1 in here to see all of the routing tables and all of the configurations that we just set, we have to input show IP EIGRP topology TT or topology table, which is very important, guys. If you watch my previous video, I completely explained what EIGRP topology, TT or topology table, and how it works. Topology table, I'm explaining a little bit right here. Topology table in EIGRP has all of the information that you need about EIGRP in your topology. So with show IP EIGRP topology, you can see the TT or topology table. As you can see, all of the networks that we specified are shown here in TT or topology table. But we don't have network 10 in our routing table. Why is that? Well, because we didn't specify the network 10 in router 4, right? And that's why we don't have any network 10 in our routing table. So we go into router 4 again, we get into the AS, the same AS number in EIGRP. Again, conf D in router EIGRP 100, AS number 100, right? And then we specify the main network, network 10, network 192.168.10.0 with wildcard mask. And after that, if I go to router 1 with show IP EIGRP topology, here we go. This is network 10. That the successors, the feasible distance with metric 3028 is shown. And as you can clearly see, guys, the links with network, both adjacencies, are shown here. Why? Because the metric in both links are the same, and the packets are going to the destination in load balance. So this scenario, it's gonna be load balance. So if, for example, one of the links are fast Ethernet with metric higher, the packets would go to the target with the lower metric. For example, if the network with 20.20.20.0 was fast Ethernet, for example, this leg, which is connected to router 3, this network wouldn't be shown here, guys. Wouldn't be showed here. You got it? So this is our metric. And because all of the links are the same, both of them are gigabit interface, and all of the metrics, the delays are the same, we have the same metric in the topology. So we have two ways to get to the target, to network 10. That's interesting, right? So we test the topology with ping 192.168.10.10, network 10, right here. As you can see, the connection is nicely working. And if I trace the packets, we trace route 192.168.10.10. And as you can see, the connection is all working nice. And if I go to network 10 PC, which show, you can see the IP address that I already assigned here. And there is an important point here. We have to assign our gateway, the default gateway in a network, in the PC, in a router, whatever you want. If you don't define this gateway here, your project is gonna be fake, right? So ping, guess what? For example, this leg, 10.10.10.10 with host ID, because we're pinging router 1, the host ID is 1. And as you can see, the connection is okay. And if I trace the packet, it's gonna through router 2, right? It's gonna through 30.30.30.2, this leg, router 2, and then get to the target, router 1. Interesting. And if I, for example, let me show you at the last stage, let me show you TT or topology table in other routers. For example, in router 2, which show IP EIGRP topology, you can see the feasible distance that, guys, look at this. As I told you before, because in router 2, there is only one way to get to target network 10, there is only route 30.30.34. Router 4 is the feasible distance. There is only one way to get to the target network 10 with metric 3072. And if I go to router 1, for example, what was the metric? What was the feasible distance metric to get to the target network 10? It was 3328, right? The metric in router 2 is lower. If you don't know nothing about metric, you can flash back to my previous video in EIGRP calculation, I completely explained and I calculated all the metrics to reach the target, and I calculated the feasible distance and successors completely, guys. So I'm not going to dive into it. I want to show something else. You can either with show IP, EIGRP, and the specific network, you can see the feasible distance and the information about the route in the specific network. For example, I'm going to input specific network 10. Oops. IP, EIGRP topology and the specific network. And as you can see, it shows you the specific network, just 192.168.10, network 10, right? Thank you guys for watching. I hope you enjoyed that. Please like and subscribe my video. I'm going to configure EIGRP named and the newer version. It's gonna be very practical. I can assure you, believe that it's gonna be very, very practical in the next video. And now I have to tell you goodbye. See you in the next video.